Hey, what's up guys? My name is Cherno, welcome back to my game engine series. So last time we did some Framebuffer stuff to do with our mouse picking journey. Check out that video up there if you haven't already. And basically today what we're going to focus on is two things. I want to talk a little bit about our general kind of Git strategy for Hazel and for this like game engine series version of Hazel, because we're going to start creating branches and various other things as we get into more complex features. And then the other thing I want to do today is deal with our clear color, because basically what we did last time, I'll show you a few things actually. What we did last time was inside our fragment shader, we were now able to, with our new texture attachment inside our frame buffer, we were able to output an integer, and in this case we just arbitrarily chose to output 50 into that actual texture so that we could eventually store our entity IDs for every pixel that we actually render. Now, the problem with this at the moment is that if we load up a scene, like this pink cube, for example, when we're over the pink cube, right, you can see that it is in fact 50. But for all of the pixels that are just in empty space, it's this weird value. The reason it's this weird value is because if we're not deliberately actually like rendering a pixel into that spot in our texture, then it's going to be set to the clear color, because that's what we do first. We clear the whole screen with a particular value, essentially, with a particular clear color, and then pixels that we actually rasterize go on top of that. Well, they get overwritten with the new values of whatever pixel we've just rendered. So again, it's fine for when we're over this, but if we're over this kind of empty space, we don't want it to be this, which is, I mean, presumably whatever our clear color is. And if we go back to edit a layer, we can see that at the moment we're using this little render command set clear color function to set it to like 0.1, 0.1, 0.1, and then 1 for the alpha. This is clearly great for our RGBA kind of main color buffer, but not so much for our integer buffer that is supposed to store the entity ID. Instead, we'd like it to be -1. So basically what we need to do is clear the second color attachment. So we have two color attachments, 0 and 1. 0 is the main RGBA buffer, and then 1 is that kind of GL red integer buffer. And again, if you don't know what I'm talking about, check out the previous episode. We need to clear that to -1, and that's what we're going to do today. So we're going to learn about clearing individual frame buffer attachments instead of everything, which is what GL clear will do. But first, let's take a little bit of a look at Fork, actually. So Fork is a Git client that I really like and that I use. This applies to any Git client out there. I just happen to like Fork. Now we have a whole bunch of stuff here that I haven't actually committed, right? So this was the last commit on the 23rd of January, which was like updated editor layer with Framebuffer API changes, and well, no, actually it was this one. That was just a little extra commit because I forgot to commit like an important part of everything. But anyway, so you can see that all the changes that we added were kind of just to do with the new Framebuffer API. But now we have something that kind of, I guess, puts me on a little bit of a crossroads, because we have a whole bunch of changes here that change the way that Hazel works, but it's not necessarily keeping it stable in a way, right? So as we embark on this journey of like mouse picking, you know, we wind up with, you know, in this case, a version of Hazel that has an extra like texture attachment inside the frame buffer that outputs the value 50, prints it to the console, and I mean, doesn't add any value to anything because mouse picking isn't done yet. So in this situation, what do we do? And this, again, this might be like a little bit of a primitive episode for a lot of you who are building game engines and know how Git works, but don't forget that this series is for everyone. So I will cover things like this from time to time. So instead of basically, you know, keeping everything in the master branch, which basically means that we have this master branch. It is like our kind of main, well, at the moment, it's the only kind of flow of the repository, I guess. Every time we commit something, we basically take a snapshot of our entire code base and any files we have at that point in time. And we can kind of scroll through and revert back to anything we want and see what changes every single time. But what if we want like another copy of that somewhat temporarily, right? I mean, maybe we'll keep it forever, maybe we won't, but we want to basically diverge from the kind of main point of the code base so that people can still access this commit, which works and which kind of, you know, has the main, let's just say, Hazel example. But then we also want to kind of branch off of that and commit in our own kind of, you know, track of code or whatever. as we develop new features that might not necessarily be done yet and might not be stable enough for them to actually be mainline or part of the master branch. So what we can do there is just create a new branch, basically. And again, this isn't like a little Git tutorial, but for those of you who are unaware of why I'm doing this, basically what I'm going to do is, while we do this mouse picking stuff, until it's fully done, it's going to be on a separate branch, which I'll call mouse picking. And then once that is done, it's going to be merged back into master. So if you're watching this series and you're wondering where the code from this episode will be, it's not going to be on the master branch, it's going to be on a different branch. And I'll actually show you how all of that works as well. So in fork, we can still go ahead and like stage everything. But what you can do with branches is just create a new branch. I'll call it mouse picking. And then now I can check out the mouse picking branch, right? I'm not going to change my local changes at all, right? Now I'm here. And then when I go ahead and commit everything now, it's going to be committed into the mouse picking branch, which has branched off of master at the commit that I was currently at, which happens to be the latest commit. If people commit in the meantime to master and those branches are now different, then you'll have to merge, but otherwise it should be pretty straightforward. Let's stage all of our changes. Now we have, so this is actually from last episode, all of these changes. I think I just cleaned up a little bit of the formatting here to make it look nicer. And yeah, so that looks pretty good. So what were the actual changes? So we added GL red integer basically as a format. Added GL red integer as a Framebuffer format plus test plus test, whatever. So I'll commit and push that. So now you can see if we go back to all commits, we're on the mouse picking branch and we've got this stuff here. So I've pushed that as well, and I did that on purpose so that I could show you guys who want to actually view that code of that particular branch. If you go to the Hazel GitHub, which is github.com/Cherno/Hazel, or you can just go to hazelengine.com and it'll take you here. You can see that we have this master branch, but then we also have mouse picking. So you actually have to click on mouse picking, and then you can view the code of what I just committed. Right? And obviously if you want to clone it, you can go ahead and like, clone the whole repository first and then do like git checkout mouse picking to check out the mouse picking branch. You can clone the, or you can probably clone, you can clone and or pull the mouse picking branch immediately, but just by going like git clone like you do here, git clone recursive, but just add a little -b and then mouse picking, and then that will immediately clone the right branch for you. Sometimes that's useful because branches can be, well, completely different. One branch might be 10 gigabytes, one branch might be 1 gigabyte, so you might want to immediately get the branch you're after so you're not just cloning stuff for no reason and waiting around. Thank you, Wolf, by the way, Wolfric, for your subscription. So, anyway, that's the basic idea. We're going to be on this mouse picking branch. A little bit of backstory as to why we like to do stuff like that. But we'll be doing a lot more of this in the future, just because obviously we basically want to leave master in a decent place so that people who just want to check out Hazel and see it actually work will be able to do so without having random stuff show up in their console and potentially, experience Hazel in a broken state. Which is now something we can do here. We could even make a commit here that just doesn't even compile. I mean, probably wouldn't recommend that unless you're doing it for a reason, but you could just commit here and not even have it compile because you have the master branch that is stable, and then this is like a development branch and anything goes there. Okay, I think that was probably a little bit of a long-winded explanation there, but hopefully everyone is on the same page now. Okay, so how do we clear this thing? How do we even clear a particular Framebuffer texture attachment? Well, there's a function that we need to run essentially called gl clear text image. That allows us to clear an actual texture with a value, right? So as always, there's this really nice site, I think I've mentioned this before, but it's a really nice little documentation site for OpenGL called docsgl. Even has a dark theme that is sometimes annoying because I think when you load a page, it goes to white first and then flips to like that. So it's like a little flash. So I don't really like that about it. But aside from that, it's a great little site. Keep it on light. You can type in a function here and check it out. So fills all a texture image with a constant value. That's a great explanation so far. Fills all an image contained. All right, whatever. Anyway, the point is that this this fills a particular image with a particular value that is inside a texture. So you can specify the texture, the level, level of a texture can region to be filled, the format, the type, and the data, right? So the idea is that we should be able to use that with specifically the first color attachment, because as you recall, we obviously created 2 textures here. One ended up being an RGBA, which was color attachment 0 technically, and we specified all of this in our Framebuffer specifications over here. We have RGBA and red integer. So for the red integer, which happens to be color index 1, or sorry, texture attachment index 1, color attachment index 1 really, we want to clear that with -1, specifically just that one. And furthermore, it's important that we do this after we run clear. So when we have our render command clear over here, that will actually clear all of the attachments in the frame buffer to this clear color. That's what GL clear does. We want to, after we clear that, we basically need to clear our entity ID attachment, we'll call it, to -1. That's our goal for today. So how do we do that, and how do we develop an API for that? So again, the function that we need to run, sometimes it helps to write this down. So let's go to Framebuffer bind, and then what I'm going to do is call that function GL clear text image, right? GL uint texture is the first parameter, so that's actually going to be the texture ID. Now we have a list of all the IDs here in color attachments, so we know that it's going to be 1. This should maybe be something that we parameterize though. Next is the level 0, that's like the MIP. Format will be, well in this case GL red integer, the internal format. Type is int, because that's the type of, I think that's the type of data that we clear with. So if I bring back our documentation, the type of data whose address is given by data, right? So this is not necessarily the type of data inside the texture, it's the type of data that you're providing with this, right? So it'll be an int, and we want to basically pass in -1. So we're going to have a value of -1, and then we'll pass in the memory address of value, and that's our function. If we run this right now, it should actually clear everything to -1. Now the problem is that we want to obviously make this a little bit more modular, so how do we deal with that? Okay, so to do that, let's go back to Framebuffer and define an API for this. So how do I even come up with an API for this? Well, clear text image, I mean, like the name itself is decent, right? We could say clear attachment, clear texture attachment or something like that. It's clear that attachments are textures. They could be render buffers, but we won't worry about that for now. We could call it clear attachment. We could pass in an index for the attachment. So this won't be a renderer ID. This will just be like 0 or 1 or 2, depending on which one you actually want to clear. Probably should mention that it's the color attachment. So maybe we could call it clear color attachment. Maybe it doesn't matter. I don't know. I don't really care about the level. I don't think we'll ever parameterize that. And then the format also, the format we can actually tell from this color attachment thing. Because aside from keeping color attachments, we also have color attachment specifications, which line up with these, and those specifications, of course, contain the actual Framebuffer texture format. So we don't need this. Now this could be useful, right? How do we specify that it's an int? Well, again, this is where it gets a little bit more complicated. So we could assume that if it's GL red integer, you're going to be giving it an int. Whereas if it's a GL RGBA, you're giving it maybe a float, right? We could actually imply that, and that might be the best way to go. And then finally, the value, we can leave it as a const void pointer. We could actually template this so that we clear it with an int or a float, and that way we could also control this, because obviously it's the data that you're providing here. But again, it's just one of those things that I don't know how complicated we want to make these. But those are my thoughts regarding designing an API for this particular function. That's kind of how I feel about it. So anyway, so let's actually put this into action now. So in the Framebuffer class, I'm going to and you know, when I design APIs like this, I don't really like to spend too long on them, because I think that it's much more beneficial for you, for an engine programmer, and for probably everyone watching this series, to just actually implement the code and then have to rewrite it, rather than spend a day planning stuff without even knowing what's going to happen with this. Because when you're learning about game engines and when you're learning about all this technology that you've never done before, trying and failing is a lot more it's a lot more beneficial to you. It's a lot better than scratching your head, because you won't even, you're not even going to know what to do, right? You don't know what this stuff is going to be used for in the future because you haven't implemented a full engine, right? So instead of wasting time kind of thinking about, oh, but what if I do this, or should I allow for that or this, just write the code. Just write the code and then change it. It's not immutable, right? It's not like this is getting printed onto, like, you know, thousands of copies of like this binder of just printed source code, and that's it. It's written. I can't change it. It's easily changeable, right? You can mutate this code however you like in the future. Not going to be huge, you know. Almost never going to be a huge deal. So just write the code and get on with your life and get on with, you know, making the actual feature work rather than concerning yourself over the API. So that's kind of, you know, that's my opinion. That's my kind of rule of thumb, I guess. That's just what I do. So that's why I never give a thought, you know, to this. I mean, like, even looking at some of the stuff here, because I was talking to the stream about this earlier. Render command set clear color clear. Like this stuff is like very primitive. Like you probably wouldn't do something like it. It's fine for now, but ultimately speaking, frame buffers should probably contain clear colors. You know, this is a great example of why a frame buffer should maybe contain a clear color, because that's another thing we could do, by the way. We could specify inside frame buffer, inside the actual texture specification, we could specify a clear color for each texture, and that way when you bind a frame buffer, it might clear it. Maybe you don't want to deal with clearing inside a frame buffer. Maybe that's something that a render pass should do, right? So maybe the render pass should have a clear color, but then maybe the frame buffer should have the clear color, but then the render pass should execute the clear when a new render pass is started, if a clear is requested. Anyway, this gets very complicated, and again, you know, that's just kind of a warning to everyone who's watching this series. I'm not copying this code from an already written engine. I mean, I do have Hazel Dev, but that's not complete either. So I'm not copying it from an already written engine or from a textbook. So this stuff will all likely change, okay? But that's kind of the beauty of it, because you get to see an engine at different stages and you get to see the code at different stages as well. And you hopefully get to see the evolution of that, which I think is really cool. All right, anyway. So to make this happen, let's just do it the way that we initially planned, which was basically a virtual void, what was it, clear attachment. I'm going to copy this attachment index, and then what do we want? Was that it? No, surely we had, no, that's it. Attachment index and value is really all we care about. So const void value, okay? So again, it's relying on the attachment to provide you with the type, and this will only let you really provide one value, I guess. But if it's RGBA, it might be, yeah. So you could probably add some asserts to make this a little bit more safe. But ultimately, it's completely reliant on the frame buffer format. And it's tied to that at the moment, which, you know, may or may not be a good thing. To be honest, this is not a very common function to run, so I don't think that we're going to end up regretting this too much. So let's do our classic little assert to make sure that we're in here. And then we need to actually obtain the format, right? So let's do this. Auto spec equals color attachment specifications at attachment index, right? So by doing this, color attachments and color attachment specifications are always equal in size. I think that's one of the first things we do here, is actually resize color attachments to the size of color attachment specifications. So we don't need to check both of them. They should always be in sync, in fact. But basically, so we've got the spec now. We can check the format of the spec, right? The texture format. So the reason we even need this is because in order to run, so let's get rid of this and let's get our example code down here. So in order to actually run this code, right, we need the renderer ID, which again is easy. So let's kind of leave this here as an example. and then we'll write our eventual line of code here. So color attachments, let me just have a semicolon so we get our thing back, our syntax highlighting back. So this is just this. Oh, right, it's the same. It's just attachment index. 0 is fine. Now, GL red integer is that format that I'm talking about. So we should be able to get that from texture format, because texture format is going to be set to red integer. So how do we go from a Hazel format to an OpenGL format? We write a function. So static GL enum Hazel texture format to GL, right? We pass in a texture, what was it? Texture format. It's a Framebuffer texture format. FB texture format, I'll do. Format. And then we just have a little switch statement. And then if I go back to here, we can basically see what the formats are. And again, you don't have to implement all of them at once, but this basically ends up being return GL RGBA 8. I guess that's kind of going to be an internal format though. Framebuffer texture format. That's what it is. I might not do this. I might just use these for color formats. Especially because it seems to be more of like an internal format. And then I like to add a little core assert false here, just because that's obviously means that it's going to be an unknown format. Okay. So, now that we've done this, and usually I like to align these. Oops. There we go, RGBA and red integer. So now you can see that what we should be able to do, right, is just do utils. I might drop this down a line, at least for now. Utils Hazel FB texture format to GL spec.texture format. Now this is, again, similar thing. Can we get a type of data from the format? And I think we actually have something like this already, or we did something similar. We had to have, right? Or did we not? Did we just do it manually? I think we did it manually. I think Hazel Dev has something like this. Yeah, so, or maybe not. Yeah, how does this know what format the data is? Oh, it's always unsigned byte. Okay. Okay, let's copy this. GL data type. We'll just do GL data type, or GL data type from format, right? So we'll give this format in, and then we'll return GL float for this. But no, this is going to be unsigned byte, I think, and there's 4 of them. They could both be int though. See, this is one of those situations where, what do you really want to provide? Okay, we'll leave it as int for now. But you could, what I would probably do ultimately, because I think, again, the problem is that this is actually nothing to do with this, right? This is tied with this. This is basically just saying, hey, what type are you providing? Because obviously OpenGL is taking in a const void pointer. It could be an int, it could be a float, it could be 4 floats. It doesn't know, right? So by providing this here, we're just saying this is the type of data that we're accepting. What I was going to do is maybe imply that the type has to be related to this, but that gets confusing because you can actually have multiple types based on the internal type as well. So it's not really a good fit. So instead, we could call this int, and then just say that this is a way to clear attachment with an int. And I think that's what I'm kind of going to do. So we'll provide an int value here. It will do that. And then that way, these are always going to be the same, and you won't accidentally ever provide a float because this function takes an int. So I think that's what I'm going to do. I was going to make it a little bit more arbitrary, but you know, you could always add another version of these that's float or even templated if you want to. But I would rather do this. And then that's kind of it, I think. So let's get rid of this. We've done it. Let's collapse this onto one line because I think it's a pretty long line. We'll make it 2. GL int and value. I think that is pretty much it. So we don't need this anymore. Okay, that's the function. So now back in editor layer, let's see if we can clear it. So M, let's actually leave that comment, that's helpful. So M frame buffer, clear attachment 1 to -1, right? And that's it. I think that should work. Let's take a look. All right, there you go, -1. So if we now open up our pink cube, you can see we have a bunch of 50s, we have a bunch of -1s, right? Everything is pretty good, okay? So that is how we clear specific texture attachments within frame buffers to a particular value. But I hope you guys enjoyed this episode. If you did, please don't forget to hit the like button below. Next time, we're going to probably finish mouse picking, honestly, or at least get a good chunk of it done, because we're going to actually make it so that when we click or when we hover over an entity, we're actually going to get the entity ID back and not just the number 50. So that's going to be quite fun. Don't forget, you can help support the series and my channel by going to patreon.com/thecherno. There'll be a link in the description below of this video. You'll get access to Hazel Dev and to all of these kind of past recorded live streams that I do where I plan these things, and it's just a really good way to help support this series and everything that's going on in the community as well. Thank you guys for all of your support. I will see you next time. Goodbye.